when I talk about complexity science, it's the study of complex systems that are dynamic, unpredictable, and multifactorial, multi-level. And these patterns emerge over time, and that's why we talk a lot about a life framework, which I'll be talking about as well, as the challenges we faced in our own work. And it really focuses around disentangling what begets asthma. And I've been very interested in that because I am an adult trained pulmonary physician as well as a public health researcher. And in my clinical work, I've been taking care of patients at the right-hand side of this, the life spectrum, when they have end-stage disease by and large, COPD. And I got very interested as a clinician in how far back do I have to go to really have an impact on putting my patients on a better trajectory, having better health and better longevity. And it really took me all the way back to the roots of it, all the way back to pregnancy, which you see on the left-hand side of the figure here. And our focus is really, initially, there was a lot of work in asthma, and my own work was interested in the genetics of asthma. And as you can see here, what we've learned with not only asthma, but other chronic diseases, the predominance of disease burden is not caused by genetic factors, but it's really primarily environmental factors. And that is the challenge. How can we comprehensively assess the environmental factors that may be driving some of the chronic disorders that we see, including asthma, lung growth, and development over the life course. Now, asthma lends itself very nicely to a life course approach as well, it turns out, and that's very fortuitous for me as a researcher. It has its roots starting in early life. It's largely environmentally driven, and it has different trajectories over the life course that depend on ongoing exposures as well as host factors. And that's not just genetics, but you can see that things like sex, girls and boys have different trajectories over time. And actually girls start to have their onset around the time that they're heading into their reproductive years, and that has implications. And then you have ongoing inflammation and remodeling, and that asthma is the biggest cause of that factor going on, and that's a determinant of lung growth and development and what happens to you over your life course. So how do you study that in a life course type of framework? And so what we've developed over the last couple of decades is this perinatal environment and developmental studies, the PEDS research program, and that we stood up a number of prenatal longitudinal cohorts, and you can see them here over the time that we had there, and each one has about 1,000 people in it, and I'll be presenting results from the different studies as we go through the talk today. And here was our challenge. We sat down and started thinking about, well, what do we know about asthma? Now this is, almost 20 years ago, so bear with me. And we said, well, what are the key driving factors that we think that we understand? And we want to measure them as comprehensively as possible. That doesn't overburden our staff and or our participants. And so we focused on a lot of the traditional measures, home environment, including indoor allergens and tobacco smoke. One thing we became particularly interested in is how the social environment gets biologically embedded, and that was through psychological stress, as shown here. And we did this in very diverse cohorts. And what we found initially was, yeah, lo and behold, we could see an independent effect of stress if we measured it with just a life course or a life event measure, and we created a continuous exposure measure. And you could actually see that there was an exposure-response relationship with the increasing number of life domains that people were experiencing negative life events. And then that, as you see the little guy running over the hill, as you anticipate that as you experience more and you overwhelm one's ability to cope, that's when you're going to start to see effects of stress, both behaviorally in anxiety and depression, but also physiologically embedded by disrupting these key regulatory systems that are pictured below: autonomic nervous system, immune function, HPA axis, oxidative stress. We look at them one at a time in a reductionist way, which is traditional, but what we really want to get to is how do you look at that in an integrated way. That's our challenge. As we went along and we repeated the measurement, not only in the prenatal period, but over the early childhood period, we started to see that there were some host factors that contributed to when they would be at highest risk. And you can see here, just looking at child sex, girls and boys are more vulnerable at different developmental windows. Boys in the blue circle are the prenatal stress seemed to have a bigger impact on its relationship to respiratory outcomes. And girls, they got the hit postnatally. And you can see through the references, you can drill down a little bit more in this. The other thing we learned is these kids aged, and about age 6 to 7, when we could do lung function testing on them, you could see that there were cumulative effects of the stress. So kids who were particularly vulnerable and had lower lung function if they experienced higher level stress in both of those time periods. So there we learned you needed to have repeated measurement over these different windows and look at cumulative effects. Well, we found that timing was even more critical when we wanted to look across in developmental windows where there's rapid changes. And it's just like the key to comedy, timing is is key to life course research, and if you want to find sensitive windows in development in particular. So here's a graphic that just shows the rapid development of the lung system in utero on the left upper hand graphic here. And so there's so many changes that are well orchestrated, well timed, and ideally what you want to do is not just randomly pick when you want to measure one point in time exposure, but boy, would it be great if you could measure every day. But of course that's expensive and it's actually burdensome, so you don't necessarily do that. But how can we, as shown in the lower part of this graph, develop methods where we could get a measure over the course of the day? And if you look at 4 or 5 different people as mapped here, they have different exposures over the course. And those who have particular increases in these developmental windows may have different manifestations clinically. Well, one way you can do that and reduce burden is to actually use Geomarker data. And this is something that's developed over the last several years as a very useful tool in environmental health research and exposure assessment. And basically what you do is you take an address, you convert the address, coordinate it to the map as you see on below. And if you can do this to someone's place of where they live, their home, where they work, where they go to school, whatever you might be interested in. And then you link that spatial location to other existing data sets to assign exposures. For example, you can do environmental pollution exposures, and you can do that on a daily basis over the course of whatever interval of the life course you're interested in. In this case, we were interested in prenatal. We worked with our colleagues at the Harvard School of Public Health and the Icahn School of Medicine at Mount Sinai to use satellite-based hybrid models using integrating satellite data with ground monitors, as you see on the left-hand side of this graph. And you can get daily air pollution exposure levels. That's great, so powerful. And now you can use data-driven statistics to let the data tell you where these sensitive windows are, rather than us making some educated guess on where we think we need to measure these things. And you can have less bias in assigning finding these critical windows, for example. That's just an important tool that's come along. And then we also measure different environmental pollutants like nitrates on the left-hand side and fine particulate matter on the right-hand side, both of which come largely from traffic-related pollution in these communities. And you can actually see that it's important to know the timing, because where these circles are showing you the effects that are significant in relationship to now not asthma, but again, lung function in these kids, there are different windows. So there are different processes during those developmental stages that are being disrupted by these chemical pollutants. And you need to understand that when you start to try to put this together in a much more comprehensive way.